We're specifically gonna look at domain and range of continuous graphs, like there can be domain and range of discrete graphs, which would be like your scatter plots where there's like each individual dot. We're gonna look at graphs that basically are continuous, like they're not just a bunch of dots. So with that, when you're trying to evaluate domain and range, for domain, you need to scan your pencil left to right along the x-axis, because the x-axis goes from left to right. Domain, if you want to also include this little note in there, would be all the x's or inputs or what else you want to call it, all the x's in a set of coordinates, in a graph, in a table, it's all the x's, all the inputs. Range is all the y's, or otherwise known as your outputs. An easy way that my students have memorized which is which over the years is Dr. XY. So that you know domain is all the x's, range is all the y's. Dr. XY. Okay, so questions on that? Okay, so then when you're looking for a domain of a continuous graph, look from left to right along the x. The domain is all the x's. For range, you scan your pencil top to bottom along the y-axis. Range is all your y. Okay, so now to some examples. So when you're told to identify the domain, and it could be of like a word problem, it could be of a graph, it could be of a table, it could be of coordinates. Domain is always all your x's. So what you're basically telling me is all the possible x's that could be on this line. All right, now look at how the line is going. When it has the little arrows on the end of the line, what does that mean? It continues, it goes on forever. And look at how, because first we're looking at domain, we're looking from left to right. Will this graph continuously keep going to the left? Will it continuously keep going to the right? So there's no x's like being excluded. In that case, since it goes continuously left and right, my domain for this is going to be all real numbers. So if it goes continuously left and right, your domain is all real numbers. Now the range is all the what in a function? All the outputs, or in other words, all the y. So my y-axis goes up and down, so look up and down. Does this graph go up? Does it continuously go down? Where does it look like it stops at on the y? At -2. So when that happens, you have to express it as like a boundary. All right, we have a continuous line that goes up infinitely. It doesn't go down infinitely. So it can be any number above -2 and including -2 because it does touch the -2. So the way that you write like your boundaries is like within an equality symbol. So the way that you represent it is whatever number it stops at. And since we're talking about range, we're going to compare it to y. Would you say that it'll be numbers greater than -2 or less than -2? Greater, because it's pointing at y's like 0, 1, 2, 3, 4, those are all greater than -2. And then it does touch the -2, like if I look at it, it is touching it, so I'm also gonna make it equal to. Questions on that? That's pretty much it. Let's do number 2. Any questions on it? So then for domain, that's all the what in a function? Inputs or your exits. So x-axis goes from left to right. Does this graph continuously go to the left? So see where it stops at. Does it continuously go to the right? So also see where it stops at there. We have 2 boundaries now. All right, as you look at the line, it's everything in between these numbers, because we have the circle touching like all the x's in the middle. So since it's domain, we're gonna use x. And you have to tell me like where it starts and ends at. So what x is right here? Where it stops? -3. And then where does it stop at on the right? +3, good. And then make sure the signs face the correct way. So I always do it like smaller number on the left, bigger number on the right. And then x, so what's actually on the circle, like 0, 1, 2, 3, is that bigger or smaller than -3? Bigger, so I need to have the opening facing the x on this side. And then compare what's on the line as far as x's go for compared to the 3. So numbers like 0, 1, and 2, are those greater or less than 3? And then take a little look. There's a solid line going through each of those areas. So it can also be equal to. So I'm also gonna have those little lines. But that's how you know, like instead of just memorizing the way that it should go, that's how you can tell, like, okay, what's actually on the line? Then I need to have it facing to where the number is bigger. Make sense? Okay, you guys try the range now for that same graph. So range is your y's and top to bottom. And write the range, kind of how we showed you. Okay, so let's see. Does this graph, the line, does it go infinitely upward? Where does it look like it stops at? At a +3 on the y. Does it look like it goes infinitely down? Where does it look like it stops at? And just out of habit, I usually will put the smaller number on the left, bigger one on the right. What letter should I use? Y, because we're talking about range. All right, so range is all the y's. So we're telling you on this graph, the y's are gonna be, well, is -3 gonna be less than or greater than y? Less than, and it does touch it because it's a solid line touching it, so we're gonna put the equals part. And then are the y's that are on this line, this circle, are they greater or less than 3? Less than. Because like the actual y's that are on here, so like here's a y value of -2. Or wait, yeah, -2, here's a y value of -1, here's a y value of 0. All of those are less than 3. And then it touches it with the solid line, so equal to 12. Does that make sense? So if it's a solid line and you always put your smaller number on the left, bigger one on the right, this is how it's gonna face. This is basically telling me it's everything from -3 to +3, including those numbers. So you kind of memorize that setup. All right. So with that, I want you guys to try 3 and 4. If you get stuck, please like call me over to you, but try 3 and 4 now. I'll give you about a minute, identify the domain and range of those. Okay, so someone sitting along that wall, tell me what you put for the domain of number 3. All real numbers, so let's see if that's right. Does this graph go infinitely left? Does it go infinitely right? So yeah, there's no boundaries. In that case, it's all real numbers. Good. Someone not sitting near a wall, what'd you put for the range? Okay, someone else then not sitting by a wall? What'd you put for the range for number 3? Okay, so let's see. Does this graph go infinitely upward? Yeah, I mean, it's not like perfectly going upward, but it is going upward, like if I keep drawing it, it's going more up with each time. Is it going infinitely downward? So in that case, the range should actually be all real numbers. So I think maybe we were looking at the y-intercept, making the connection there, but it goes infinitely up and down. So we go all real numbers for that one. Make sense? Okay, so then number 4. Someone from the middle of the room, what'd you put for the domain on number 4? All real numbers, you guys agree with that? Okay, so let's see. I know this graph, like as it's going down, it's getting wider. As it continues to get wider, will it eventually touch all the X's on the left? I mean, it has the little arrows on the end, so it's infinitely going, and it's getting wider each time. So that means, yes, it will eventually touch all the X's. So it is all real numbers for the domain. That is true. This is a quadratic function. You'll see that second semester. For those, the domain is always all real numbers when it's like those U-shaped graphs, either going down or up. But yeah, anyway, someone along that wall, what'd you get for the range on this one? Why something 4? Okay, why something 4? Can someone help out with what the something should be? Okay, you guys are both right. 4 being greater than y and y being less than 4, that's still supporting that. But anyway, yeah, so let's look. Is this graph going infinitely upward? No, see where it stops at on the y, and it does stop at 4. So we're gonna compare that number to y. Does the graph go infinitely downward? Yeah, so I only have one boundary, I should just have one inequality. And then you have to see, look at the y values that are on this line. Like if I pick this coordinate, that's a y value of 3. Here's a y value of 2. Here's a y value of 1. Are all those numbers smaller or greater than 4? So then I should put that y is smaller compared to 4. And it does touch the 4 exactly, it's a solid line touching that area, so we're good there. Questions on that? Okay, so I do have a Kahoot prepared to like practice this. But are there any others that you saw on the notes, front or back, that you kind of just want to look at? Or are we kind of getting the gist of it? Any that look difficult? Okay, number 7, let's all take a look. So domain is all the X's. So look from left to right. Does this graph look like it's gonna go infinitely left? Yeah. It has this little arrow here, meaning that it's gonna continue going in that direction. And it kind of looks like it's getting wider as we do that. So infinitely left, I'd agree. Does it look like it's going infinitely right? So then what's my domain going to be? All real numbers for my domain. Because it does look like it'll go infinitely left and right. For the range, so scan up and down. I feel like I actually might need the key for this because I don't know if it's supposed to continue this pattern or if it's going infinitely that way. Let's go with that. It's going infinitely that way. So would you say that this is going infinitely up? Would you say that it's going infinitely down? So then because these arrows are here, I would also say all real numbers for that one. If it stopped at like a point, like if it didn't have the arrow, then I'd probably change that to say like, oh, it stops here on the Y and here on the Y. But since it has those arrows, we're gonna assume it goes infinitely in that direction because that's what those arrows mean. So questions on that one? Yeah, so if it did continue the pattern, then yes, the upper boundary would be where Y is 2, and then the lower boundary would be where Y is -3. So like, if that's what I wanted you guys to look at, then I would make these dots to see like, okay, now it ends, now it's my domain range. But we won't do that. We'll just leave it with the arrows and assume it goes on infinite. All right, any other ones you guys want to look at? Okay, so then instead of giving you like a worksheet practice, because I do have those, we'll just do a little quick Kahoot. And it is not just these continuous graphs, it's also like from a table or from a list of coordinates. But you need to know domain is all your X's, range is all your Y's. So really giving you a lot of good skills here in this lesson. But here's the Kahoot. I'll make the note taking, like instead of giving you a new sheet to take notes on, you could take notes on that free space, that little half space that you have. And I'll make it more optional. So that doesn't mean you get to just disengage and like randomly pick answers. But if you like are learning new stuff about domain and range, then write it down in that free space. All right, but there it is. So I'll only grade you on participation. Notes will be optional, but that doesn't mean you get to disengage. Right, so. So if you make $8 an hour to compute the amount made in a shift, the hours worked is the domain or the range? Is it the input or the output? if you make $8 per hour to figure out the amount made in a shift, would the hours worked be your domain or range, your input or your output? I told you, you have to find domain and range of lots of different things. Situations is one of them, but basically like, what's your input, what's your output, what depends on what? So like, say I was gonna graph this. And I'm comparing what two things in this situation? What are my variables? Okay, so where would I put the amount made? Would I put that on my y-axis or my x-axis? Good. Because the amount made depends on what exactly? So the hours worked. That's how you would graph it. Usually time of some sort is on your x-axis. So that means these are my inputs, my domain. All right, it's lots of like different synonyms for what your x's are. Inputs, independent variable, what else? Domain now. So that's how you figure that out. Questions on that? Okay, so then on to the next one. All right, for the relationship, there's a bunch of coordinates. The domain is what? 1, 2, 3, 4, 1, 3, 5, 2, 4, 6, 3, 4, 5, 6. Only what I told you about the domain. I give you a list of coordinates, my domain is what? All the odd numbers? No, not necessarily. X's. And how do coordinates go? In what order? So if they're given to me as a list of coordinates, all the numbers that come first in each coordinate are my x's, therefore that's my domain. All right, when you write your domain, if you have numbers like x's that repeat, you don't write them multiple times. But it's basically like a list. It's saying my x's are these numbers and these numbers only. I don't put in any equality because it's not all the numbers from 1 through 5. It's just like a list of numbers. Make sense? Any questions on that? Okay, so then on to the next one. For this relationship, the range is what? It's a list of coordinates. What's the range? You do not need the picture. All the y's. So then when it's given to you in coordinate form, y's come second. So then all the second numbers in each coordinate, 2, 4, 6 in this case, is your range. Questions on that? Okay then. So next one. For this relationship, what is the domain? So coordinates. This time, what is the range? So class, when we talk about range, what are we talking about? The y's. So again, let's say it like 10 times. Everyone. Okay. The range is all the what? The range is all the what? The range is all the what? Debbie? Okay, good. So maybe we won't say 10 pounds. How do coordinates go? In what order? X and Y. Let me make that look more like an X. X and Y. X and Y. So if range is my Y's and it's asking me what my range is, I only want the Y's. Make sense? Any questions? You seeing the pattern? Okay, so then on to the next one. All right, so for this relationship illustrated below, the domain is, let me make that bigger if I can. So for this illustration, my domain is what? Okay, so now this is given to you in what we call a map. Anyway, domain is all your inputs, all your X's. So it would have to be what's here on the left. Usually they put it on the left, but it's what this is turning into, I guess you could say. It's this number pointing to that number. So this suggests that these numbers over here are my outputs, my Y's. This is my inputs, my X's, and we know domain is all the X's. Okay, good. Okay, so then on to the next one. So for this relationship illustrated below, what is the range? Now for this illustration, what's my domain?